everyone. I'm Tejal. I'm a researcher on the reinforcement learning team here at OpenAI, and I lead our Frontier Evals efforts. And soon I'll be joined by Henry, who leads our Evals product. We'll be doing a Q&A at the end, so please drop your questions in the Discord, and thanks so much for coming. So here at OpenAI, we're training some of the most powerful AI models in the world. And to understand what these models can do, we need to evaluate them. Evals measure the capabilities of our models so we can steer model training towards good outcomes. So we're very excited to share with you today, first, how we evaluate frontier capability progress here at OpenAI, and second, how you can have practical tools to run your own evaluations on your applications and agents. So why does evaluation matter? At OpenAI, training runs are very expensive in terms of compute and researcher time. So we need signal to measure progress so we know how the run is doing, and we can intervene and steer training appropriately. Historically, we use classic academic benchmarks like the SAT or the LSAT or the AMY, which is a high school math competition, to push forward reasoning capabilities. But these evals can only measure so much. For example, when we were starting to train O3, we didn't know if we were making progress because we'd already gotten so close to 100% on all of these benchmarks, and yet our models weren't yet able to do real-world work, so it was clear we needed a new way to measure progress. You can think of these classic benchmarks like you'd think of hiring a straight-A student out of high school. Sure, they're great at studying and passing tests, but they're untested in terms of work in the real world. And we all know that can be a tough transition. This is me in my first internship, being so behind at my work that I was coding at the team drinks, and my team made a lot of fun of me for that. So that's why we're transitioning from tests to measuring work like a drop-in coworker would actually do to understand how models can support people in their everyday work. To do this, we built GDPval, which is named GDPval because it covers tasks relevant to GDP, or gross domestic product, and it measures how our models can do on economically valuable, real-world tasks. It's available on the OpenAI website, as well as Hugging Face. So when we launched GDPval in September, it really took off. A lot of people in the community were talking about it and using it. But to understand why, I'd love to show you a few examples of what this eval is actually measuring. All of the tasks on GDPval were made by experts with an average of 14 years of experience in their fields. They're the best of the best. And we wanted to measure how models can stack up against these experts on real-world work. So here's an example. We have a real estate agent that's taken some pictures of a property they want to show, and they've done some research on that property, and then they want to make a brochure to show that off. And we're interested in how can our models do compared to this agent. And you'll notice that the tasks in GDPval are very long horizon. They often take days or even weeks to complete, and they're very multimodal, so often involve a lot of computer use, images, and tools. Here's another example. A manufacturing engineer is creating a 3D model of a cable reel stand. Again, very multimodal. It involves an actual piece of real-world work someone had to do. And final example, you have a film and video editor that's creating a high-energy intro reel with audio and video. So those are just a few examples. We actually cover a lot more. We started with the top 9 sectors that contribute to US GDP, as per the Federal Reserve. So every industry that we include here contributes over 5% to US GDP. And then within each sector, we selected the top 5 knowledge work occupations that contribute the most to overall wages, as per the Bureau of Labor Statistics. And then finally, within each occupation, the government actually tracks what are the main tasks that someone does in that job. So for example, if you're an accountant, you might be looking up external information, you might be creating a budget, you might talk to a client. And for every occupation, we cover the majority of work tasks in that occupation. So overall, this yields over 1,000 real-world tasks covering real estate, CAD design, retail, really trying to understand how models can do real-world work. So those are some examples of the tasks we test. The natural question is, how good are we at these? So first, let me explain how we grade our models. So we use pairwise expert grading, where we compare a model's outputs to a human expert's deliverable. And then the graders in the field are blinded, so they don't know which is which, and they select the one they prefer. And we roll these judgments into an overall win rate, which is the percent of times the model's output is preferred. And this gives us a clear and unbiased measurement of capability on real-world work that we can track over time. So here's my favorite plot. So the y-axis, we have the win rate versus an industry professional. And back in spring 2024, I helped work on the GPT-4o model, which at the time we thought was like the frontier, best model we had ever released. But actually on GDPval, it scores less than 20% on win rate. So the vast majority of times, an expert would not want to use GPT-4o instead of just having them do the work directly. But already over the last 18 months, with GPT-5, we're getting close to 40% win rate on these tasks, which means that in half of the times, nearly, experts would prefer the model's output or think it's just as good compared to something a human could do. And if this trajectory continues, you might just imagine, where would we be in a year or two? Maybe we'll be actually at parity. And in fact, there's already some models in the industry like Claude here that's already getting really close. So these models are going to be able to do the kinds of applications you guys care about quite quickly. I'd love to do a little explainer. This is a very simplified task where we have a nurse practitioner that's making a deck to explain hypertension. And I'd love to see how you all do in guessing which one is the model versus the human. OK? So raise your hand if you think the example on the left is the human expert. Couple hands? Maybe like 10% of hands. Raise your hand if you think the right one is the expert. So if you like the left, turns out that one's the model. The right is actually the expert. But you might notice they're pretty similar. Like, you can't really tell the difference. They both kind of get the job done. And if you look into the time and cost of getting this kind of output, the models are significantly faster and cheaper than humans, where you see in our paper we have some more detail that if you have a model in the loop when completing these tasks, you can save a lot of time and money compared to doing the task unaided. So why did we build GDPval? The first reason is that understanding how AI can impact labor is a very commonly asked question, and the current methods used by economists often involve looking at usage data. So how are people using these models in production? But the problem with this is that it's very much a lagging indicator. And for most large technological shifts, it can take years or decades for actual usage to show through in GDP. So for example, airplanes, electricity, the internet, the time from inventing an airplane to most people using it to get around for work took decades. And we suspect AI will be the same due to regulatory reasons, cultural reasons, procedural reasons. And so evaluations help us proactively track and communicate how our models are doing on real-world work. And then also, internally on our research teams, we're using this as a North Star to guide and track model progress. So if you're interested in this evaluation, you can evaluate your own models at evals.openai.com. We've also open sourced the eval stat on Hugging Face, where it's already reached #1. And you can use any of the data sets there. And then finally, we provide a public grader service so that you can iterate on your own results. So I'd like to caveat a lot of limitations. I saw some discussion on Twitter that was like, OpenAI automated all jobs. That is like not what this eval is saying. It's measuring how models can do on a set of well-specified tasks that have a clear input and output. And as you might imagine, in real work, there's like a lot more than that. You have to figure out what even to work on. You have to prioritize tasks. Your manager might give you feedback, and you might iterate. And so we're working on making future versions of GDPval that incorporate this. But in the meantime, we're really excited about GDPval making a lot more progress than these academic tests to understand how our models do on the same kinds of tasks that many of you are building for. So that's how we evaluate frontier models at OpenAI as we build them internally. But if you're building on the OpenAI API, you might also want a way to evaluate your models with the same rigor for your own custom use cases. And that's why Henry from Product is here to show you how.
Thanks, Tejal. Teams that invest in evals, they build consistently better products. And we see this pretty much every day here at OpenAI. Not just when building our frontier models, but also from our work with some of the world's largest enterprises, some of the world's most sophisticated startups. We work with these companies to help them deploy AI to production every day. And from that work, we've seen how critical evals are and how crucial they are to get right. I'm going to share today what we've learned from this work and how we're making those lessons available to everyone through our product. So why do evals matter for builders? People who are building agents, applications, not only people who are making frontier models, such as OpenAI. It's because building high-performing AI applications, it's still really challenging, right? It's not easy. LLMs, they're infuriatingly non-deterministic. New models keep dropping. And with chat, the edge cases are pretty much endless. It gets even harder when you're building an agent, and error rates compound with every call. Then you combine this with user expectations. They're super high, and they're only getting higher over time. And errors, they can be really costly. People are building agents in regulated domains now. Think finance, legal, health. Wanting to get these use cases right is crucial. User expectations through the roof, and you have no tolerance for failure. So I think we can agree, evals, they're a crucial pillar of building any AI application. but today they're really hard to get right. You have to spend what seems like forever compiling representative data sets of inputs. You have to create and align graders that really capture your business preferences. And it's so time-consuming, some people just skip it altogether and ship straight to production based on vibes. We're working hard to improve this here at OpenAI. We have an Evals product, and today we've shipped a whole bunch of new features for it. This product, it aims to make defining and running Evals much easier and increasingly automated. Today, we've introduced a host of new functionality to make it easy to build Evals, to run Evals, and especially to run Evals for agents. First up, datasets. This is our visual eval builder. Makes it easier than ever to get started building your first eval, as well as to complete human annotations in one easy surface. Next up, traces. Traces are an incredibly powerful tool when you're building an agent or a multi-agent system, but they're hard to interpret at scale to find those faults when you've completed many runs. Trace grading allows you to run graders over those completed traces, identify those problems, and direct your debugging efforts directly to those failing traces and those problematic spans. And then what do you do once you've completed an eval run? You have a ton of relevant information from a prompt, a bunch of grader outputs, and potentially human annotations too. Well, today you have to read through all of that data, find patterns, maybe do some prompt engineering. But a better way is automated prompt optimization. This is where we take all of those inputs, the annotations, the grader outputs, the original prompt, and we rewrite that automatically to massively accelerate your iteration time. Next up, a really common request that we've had throughout the lifespan of our product, third-party model support. So when you're using our Evals framework, thank you. When you're using our Evals framework, you're not exclusively tied to OpenAI models anymore. You can evaluate across the ecosystem. And this has been implemented for our partnership with OpenRouter and Bring Your Own Key, so you can support any custom endpoint. And finally, our product's enterprise ready. We're available to organizations with zero data retention enabled, and we support enterprise key management as well. So that's enough talking. Let's get into a demo. I want to talk you through an example that Carlyle, the leading global investment fund, built using AgentKit. This is a use case that is much simplified, but for reasons that I will not go into, I wanted to make something that was like simple and easily visualizable. So the goal of this is to take a company, provide analysis from various perspectives, criticize those perspectives, and then come up with a final report that a professional investor can use to inform their workflows. So here you can see the visual agent builder that was demoed on stage earlier. You can see we take an input, pass it through various agents, and then write a report that gets returned to the user. Now, building a multi-agent system is complex and challenging. Your agent is only as good as the weakest link, as any one of these specific components. So initially, you want to evaluate each component. So if I click on one of these nodes, I can see an agent. This is a fundamental analyst that is going to conduct financial analysis into a provided company. Now, we could just run with this node, but a better way would be to build a simple eval for it. So if I click Evaluate, this is going to open that agent that had been defined in the visual agent builder, and it's going to open that in our new datasets product. It makes it easier than ever to create that eval. So here you can see the model that we had used. We can see the variables and the tool cool has been passed through. We can see the initial prompt. And then we can upload just a set of sample data, just really basic, couple of rows. So this is now a basic data set that we can use to test this application with. You can see I've got a couple of companies that I feed into this prompt. And I've got a couple of columns here of ground truth values so that we can make sure that web search tool is pulling in the correct context from around the web. So this is going to run through and complete generations here. And as those generations are completing, we can click in. We can read what the actual generation has been. And we can do a couple of things. First up, we can add annotation columns. So this is a really powerful tool to conduct manual subject matter expert annotations. So here, let me add a rating column, and then let me additionally add a free text feedback column so that I can attach those kind of free text annotations to. So what I can first do is I can read through these. I could find some challenges. I could rate, maybe that one's good, maybe that one's bad. And I can add free text feedback. Maybe this is too long. I could also use this to rewrite that generation and create a golden response. So subject matter expert annotations, super powerful technique when running evals, and really it's crucial to lean into them. But they're very expensive and don't scale well. So a better solution is to also use graders. So here we're going to just create our first LLM judge, a simple grader that's going to run over those generations. And in this example, I'm going to ask the judge to just evaluate a financial analysis and ensure that we see upside and downside arguments, comparison against competitors, and a clear buy-sell hold rating. I'm additionally going to ensure that the quarterly revenue and income figures that I pulled in are consistent with those ground truth values that we have in that reference data set. So now I can save that grader, and that's going to take these generations, pass them into that LLM judge, and then create a response, which I'll be able to see here. Now, running grading can take a minute while the inference completes, but like a good TV chef, I've got an example of one that I made earlier. So here we can see this grader that's completed, and we can read through this rubric and understand why a failure might have occurred. And here, for example, we can say that the response does not compare the given company against any of its peers, and there's a couple of other failures too. So what could we do here? There's a couple of things. First, you could read through all of those failures and then do some manual prompt iteration and try and iterate on that manually. A better way is to optimize this prompt automatically. So I've clicked this optimize button down here, and a new tab has opened up where it's rewriting the prompt with an agent. This is going to take that data, those annotations, the grader outputs, and suggest an improved prompt. Now again, this is going to take some time to come through, so we're going to click ahead to one that I made earlier. And here we can see a diff view. That original prompt, which we were using, pretty simple, couple of lines, didn't actually capture all of the criteria that I wanted the generation to consider. And here we can see this automatically rewritten prompt, which is significantly more thorough and aligned with the preferences that I have kind of encapsulated in that manual annotation. So that was that first step. That's how I took that multi-agent system, took a single node, and evaluated it. You also want to look at the end-to-end. You want to make sure that this whole system is working as intended. To do that, traces are a great tool. So here we can see a set of traces that have been created from this agent. We can then attach graders. In fact, I'm just going to delete these ones I made earlier. So we can then attach graders and say, as we've been scrolling through these traces, we find some problems. And let's say we want to make sure that cited sources are authoritative first-party sources and not news aggregators. Let's say we scrolled further and we got to the end of the generation, and we found another problem, that the final output needs to have a clear buy-sell hold rating. So the workflow here is to build up a rubric, a set of tests that you want to run over these traces at scale. You create them here as you're tabbing through many of these traces. You can scope however many you want to kind of test. And then once you've built that rubric up, you can click to grade all. And this will run those graders over many traces at scale, so you can find the problematic examples to dive into. So that was a real quick overview of how you can take, actually, let me just show you what that looks like when it's run. So obviously, it takes a bit of time to run one of these evals, because the trace is very large. So here you can see this is coming through, and you've got the graders. But once that completes, I'll go again to one that I made earlier, and you get a view like this, where you can see those grader outputs at scale, and I can click through any one of these traces and understand where there's been problems so that I can accelerate that trace review process rather than reading through dozens of them at any one time. So that was a real quick overview of how Carlyle can build an agent using our agent builder, but then crucially evaluate a single node and then the whole multi-agent system end-to-end, which allows you to be confident in the performance, which is obviously so crucial if you're in a performance-sensitive domain. So when you're deciding how to run evals and what tooling to use, there's a couple of things that we think are really worth considering. The first is integration with a kind of a horizontal set of tools that contain everything you need in one place. We're building that in the agent kit from the product. This provides tight integration from building an agent in the builder, as well as the agent's SDK, easy deployment tools, and now easy optimization tools, so you can complete that iteration loop all in one place. Next up, automation. I showed you today how prompt optimization can accelerate that journey of building a high-performing agent. We want to go further and allow you to generate and align graders and generate data sets based on representative user inputs. So keep your eyes peeled for those coming soon. And then finally, we're really trying to lean into ease of use. making it straightforward to get your subject matter experts in a tool, capturing their expert preference data in one place, and reducing the barrier of entry to running evals, which today can be challenging, somewhat intimidating. So the final lessons that we've picked up from working with lots of customers over the last many years is starting simple and building evals right at the start of that development process. Don't wait till the end and do a bit of ad hoc testing. Define a simple set right at the start and evolve it as you build out your application. Next up, use real human data. Don't come up with hypothetical examples, hoping they're going to be representative of your real users. Instead, sample real past user inputs and use them as the basis of your eval set. And then finally, annotate with subject matter experts and spend the time that you spend on evals really making sure that preference data is being captured by your graders, by your prompts. And let some of that manual repetitive work, like prompt optimization, grader alignment, let's try and get that to be automated so you can focus on the tasks that matter. So we really see rigorous evals enabling anyone to build high-performing products. And they're a crucial part of that development journey. And today, you've seen how we evaluate our frontier models here at OpenAI and how you can evaluate your applications using the same rigor through our new product.